Alright, to solve an equation by factoring, we need to get 0 on one side of the equation, which this equation already has that going on for it. So now that we have 0 on one side, we factor the other side. It looks like we have a trinomial to deal with. First, we check for a GCF, a greatest common factor. But there is no term that goes into all three of the terms, 8x squared, 57x, and 56, other than the number 1. So there is no GCF that I can factor out. All right, so we have a trinomial where the leading term does not have a coefficient of 1. The leading coefficient is an 8. So I'm going to use what's called the trial and check method in order to factor this. So this trinomial is going to factor into two binomials. The first two terms of these trinomials have to multiply to 8x squared. So what I'm going to do is identify some possibilities. It could, 4x and 2x multiply to 8x squared, so 4x and 2x could be the first two terms in my answer. Or maybe it's 8x and 1x, right? Those are two pair of terms that multiply to 8x squared. Normally it's best to try the terms that are closer together, the 4x and the 2x. So normally I would try the terms that are closer together. 4 and 2 are closer together than the 8 and the 1. But it turns out these two terms won't work because the numbers in the back, these numbers, they need to multiply to negative 56. But and so maybe it'd be like 8 and a 7 or something. But I wouldn't be able to put 8 in the backs of these trinomials because then there'd be a GCF. 4 and 8 have a GCF, or 2 and an 8. So this has prompted me to feel like the 4 and the 2 aren't working. So I'm going to try the 8x and the 1x. Now the numbers in the rear, the numbers in the back, they have to multiply to negative 56. And the first numbers that come to mind would be like 8 and negative 7, or maybe the negative goes with the 8. Of course, it could be other numbers like, what else multiplies to 56? Like 4 and 14. 4 and negative 14, or maybe the negative goes with the 4. I'm going to give the 8 and the 7 a try because they're closer together. I'm gonna do this wrong on purpose. Let's say I put the plus 7 there and the negative 8 here. Now this right here is a potential factorization. Notice that the first two terms, the 8x and the 1x, they multiply to 8x squared. And the back two terms, negative 8 and the 7, multiply to the negative 56. But it's the middle term that's in question. To check out the middle term, we can multiply the inner terms. And we can multiply the outer terms. And these two terms, notice that they add up to 48x. But what do we need them to add up to? We need them to add up to negative 57x. So this shows that this factorization is incorrect. Another thing right away is notice that I have a GCF here of 8. And since there is no GCF in the original problem, there shouldn't be one here. So again, I did that wrong on purpose just to show how we would check it. Let's try let's try switching them around. Let's say I put the negative 8 here and the 7 here. Now notice that I have 7x and negative 64x. And these two terms, the 7x and negative 64x, they add to negative 57x, which is exactly what I need. So this is the correct factorization. It's tough factoring by the trial and check. It takes practice. And not only that, but this one's a tough one because these numbers in the trinomial are so large. I suppose if we are ever stuck and it says solve the equation by factoring and we weren't able to factor it, we could use the quadratic formula. But now that I have it factored, we set each factor equal to 0. So we're going to go So we're going to go 8x plus 7 equals to 0, and x minus 8 equals 0. So we have x equals 8 as a solution, and subtracting 7 from both sides and then dividing by 8. So the solution set consists of the numbers negative 7/8 and 8. All right, so they want me to solve this equation using the quadratic formula. So to use the quadratic formula, we first have to have the equation written in the standard form ax squared plus bx plus c equals 0. In other words, we need 0 on one side, so this equation already has that going on. Once I put the equation in this form, that allows me to identify the values of a, b, and c. It looks like a is 1, a is the coefficient of x squared, b is 6, and c is negative 1. Now that I've identified these three numbers, we're going to substitute them appropriately into the quadratic formula. And recall that the quadratic formula is negative b plus minus square root b squared minus 4ac all divided by 2a. So we're going to substitute the numbers into the quadratic formula. So doing that, I have x equals negative b, so that'd be negative 6 plus minus the square root of b squared, so 6 squared, minus 4 times a times the c, all divided by 2 times a. And now we start simplifying this. So we have negative 6 plus minus square root. 6 squared is 36, and then the product of negative 4, 1, and negative 1 is 4. And on the bottom we have 2 times 1, that's 2. And the next step I'm not going to do much. All I'm going to do is add the 36 and the 4. All right. So the 40, which is the b squared minus 4ac, that's called the discriminant. Since 40 isn't a perfect square, that shows us that the original problem cannot have been solved by factoring. If 40 was a perfect square, I would now square root it. It isn't, though. But we do the next best thing. We simplify it. So I have to simplify square root of 40. To simplify square root of 40, we ask ourselves, is there a perfect square that goes into 40 evenly? And there is, a 4. I can rewrite 40 as 4 times 10. And then I can square root the 4. The square root of the 4 is 2, and the 10 stays in the box. Okay, so I simplified square root of 40. I can rewrite square root of 40 as 2 square root 10. Finally, notice that the negative 6 and the 2 in the top can be divided by the 2 in the bottom. So I'm going to do that. Negative 6 over 2 is negative 3. And then 2 over 2 is 1. It's not essential to write the 1 there, though. We could just write negative 3 plus or minus square root of 10. And that's it. If you enter negative 3 plus minus square root of 10 into MyMathLab, it should accept it. Alternatively, we could express the answers as 2 individual numbers.